Okay, so in this video we're just going to go over some basics in polar coordinates. So first we'll look at plotting points. So plotting polar coordinates. All right. Now recall, if it's specified that it's a polar coordinate, then we treat it as a point that contains an r, a distance from the pole, and a theta. Right. So for example, let's say let's plot two of them here, 2, and let's say 3 pi over 4, and then we'll plot -2 and about 7 pi over 6 as an example. Okay. All right. So let's say our goal was to plot both these. Let's name these here A and B. All right. Now, as if you recall from our intro, right? So the way we're going to plot this, we plot our polar axis along with the pole. Get out a straight edge here. Sorry for all the noise there. All right. So let's say here. Alright, so we have our polar axis. I think of it as our initial side here. That's the pole. Alright, so here, 1, 2, right? As an example, let's say that was 1 unit, 2 units. Alright, so 3 pi over 4. That's going to be somewhere in, when we think of our Cartesian coordinates, somewhere out in quadrant 2, or a little bit less than 180 degrees or pi radians. Right, so again, just looking for an approximation here. Let's say it's somewhere over here. Right? So here, it'll be always 2 units. So something like this. All right. So that'll be our coordinate there. This line is just to kind of, I just drew it to emphasize that that distance there would be 2, and this angle theta here, right, that is 3 pi over 4. Right, and that's how we can draw one with a positive r. Right, now the negative r gets kind of tricky because we talked about reflecting it across the origin there, right? And the origin is kind of, well, here let's develop a way to plot something like this. All right, so I would start off, so what I would do when we're plotting negative r's is I would start off the same way, where we have our pole. All right, excuse me. Excuse me. So we have our pole, and I would treat this no different than the previous problem where we had a positive r. All right, now 7 pi over 6 is a little bit more than pi radians, so the angle itself would be, let's say, somewhere here, right? Where again, if the pole extended in this direction, the reference angle here down here would be pi over 6. So what I would do is I would say, all right, let's say that here I would draw right, a dotted line here. Since it's negative, it'll be the point reflected across here. Now the way I can kind of, again, just plot it here as a sketch, instead of right being here, it's the straight line that you can make with the pole and the point if it were a positive value. Right, so the point actually here would be out here. Where again, right, our angle here is this one here. Right, but since it's negative, it gets reflected across the pole here. All right. And that's how I would approach plotting a negative value for r. Right? And of course, the plotting here, so the name for this point is not unique, right? If we go from here 2 more pi radians, right, that brings us back to the same point. So another name for the same point. So you can come up with multiple points as well, right? Including positive and negative r's, right? Because if we think of in the same way we found that one, right? The reference angle here is pi over 4, right? So we could rename this as negative pi over 4, so we're going in this direction, and negative 2, right? So negative pi over 4 brings us here, but the negative reflects it across the pole, so it's over there. Okay. Okay. So that's just a couple of examples of plotting polar coordinates, right? Another thing that we will be doing is converting between rectangular coordinates and polar coordinates. So in order to do that, we need conversion factors or something that relates both of those quantities, polar and rectangular. Okay. All right. So what we have here is, if we remember from our introduction, right, those points lie on a circular as we move through theta. Well, not necessarily always the unit circle, but some circle of radius r. So what we can do is, kind of adjusting from our unit circle to some radius r, x is going to be equal to r cosine of theta, and y is going to be equal to r sine of theta. All right, so this gives us a way, if given, excuse me, if given coordinates here in polar form, that we can calculate x and y. All right, now to go in the other direction, we need these conversion factors. All right, and again here, always provided when we're dividing, make sure we stipulate that this holds unless x does not equal 0, in which case the tangent of theta is undefined. Okay. All right, so for example, let's say we wanted to go from rectangular to polar. All right, so let's say we're given the point okay. All right. Okay, so let's say we're given the point 2, negative 2 root 3. All right. Okay, so again, one thing here to notice is this point is going to be somewhere out here, right? So P. So we're given that this is rectangular, so this point will be somewhere 2, negative 2 root 3, so in quadrant 4. Somewhere there, right? Again, just an approximation. So I'll start here by, we can find r. R squared is going to be x squared plus y squared. Right, so here we'll have 4. Negative 2 squared is positive 4. Root 3 squared is 3. So we get r, that's 12 plus 4, 16, excuse me. R is plus or minus 4. Remember, whenever you take the square root of a, excuse me, whenever we take the square root of a square, we get plus or minus. Now, which one you choose? Now, if we recall from our previous examples, there are several ways to name, or an infinite number of ways really, to name a polar coordinate. So it's up to you. All right, I think here the most straightforward one is always just stick with the positive. That way you don't have to take into account the reflection. All right, so let's say that r is 4. So now let's find our theta. All right. So here's where our previous trig knowledge will come into play. All right. Tangent of theta is equal to y over x. All right. Okay. All right. So tangent theta equals to the y value, -2 over root 3 over 2. Simplifying this, tangent of theta equals to -root 3. All right. Okay. Okay, so here we have theta to be -pi/3. Or a reference angle of pi/3. Right? So what we can do is one way to excuse me. All right, if you wanted to have a positive theta, right? Let's say that I did for whatever reason, I just asked to find a positive theta. All right, so here, if the reference angle is pi/3, then this angle here would be 5 pi/3. So we can have our polar coordinate to be 4 5 pi/3 in polar coordinates. Okay, and that's how we can go from rectangular to polar. Okay. All right, so let's say we wanted to go the other way. The other way being from polar coordinates to rectangular coordinates. From polar all right, so let's say we're given a point 5 7 pi/4 in polar form. Okay, so here again, remember what this represents r and theta. So looking at our conversion factors, I can see right away, well, I can use here to find my x coordinate. X would be equal to r cosine theta. All right, plugging these values in, x is 5 cosine of 7 pi/4. Right, 7 pi/4, right, that's on our unit circle in quadrant 4. So cosine is positive, so 5 times root 2 over 2. So x is 5 root 2 over 2. All right, we'll keep it exact. Now our y coordinate is going to be r sine theta. So y would be 5 times sine of theta, and of course sine of 7 pi/4. All right, here in quadrant 4, the sign is negative root 2 over 2. So y is -5 root 2 over 2. Okay. All right, and that is how we convert from polar into our rectangular coordinate over 2. Okay, thank you.